Welcome to DevGAMM Lisbon. My name is Rob Carr. As you can see, I am the senior sound designer, or I was the senior sound designer at Redhill Games. I have, since the beginning of this year, I have changed my career path to being a mission scripter. Let's address the elephant in the room. The reason why I did this was because that was the need of the company, and anyone who spent any amount of work, any amount of time in the games industry will realize very, very quickly, most people will be able to help in certain design elements and certain sort of development aspects of game development. So it was a fairly natural sort of transition. We are currently working at Redhill Games. We are working in co-development with Blizzard, and I can tell you that we are working on Overwatch 2. That is all I can tell you. I can't tell you anything else about the work that we're doing. This talk is not about anything that we are currently working on with Blizzard. This is a talk which is based around having your audio team as designers, or allowing the audio team to be designers and giving them creative freedom. There's a really good reason why we're going to do that, and we'll look into that. Okay, what happens when people find out you work in the games industry? This is one of my favorite topics. Oh, it must be nice to sit on your ass and play games all day. No, I'm so busy making video games, I don't have time to play video games. That's just not how it works at all. You know the problem with insert game that you worked on? It's this, and this is how you should fix it, as if a team of 100 people working for 5 years didn't already think of any of that. And my personal favorite. Oh, cool, I've got this great idea for a video game. No, you don't. You have a good story. A good story and a good narrative, that's not a video game. A video game is very, very different to that of a story. So what's the difference between an audio designer and a game designer? Okay, so this talk is going to be mostly centered around audio design, but also game design as well, and how the two are intertwined. Now, I always use the definition as an audio designer creates an instance surrounded by a context. So a gunshot sound is a really good example of that. It's an instance, which is a bang, surrounded by a context. Oh, it's a gun. It doesn't make the bang until I fire the weapon. A game designer, they do it the other way around. They create a context surrounded by an instance. So the instance is the gun in this particular case, but the context is, there's enemies coming from everywhere. That's the difference between an audio designer and a game designer. So when we deal with game design and audio design, what are the main problems that you're going to face is iteration. Audio can only base its entire workflow on up-to-date information. And that information will change all the time because your game designers are always changing things because some things don't work, some things, like, it works in principle, and then you actually put it into the game, and then you play it, and you're like, actually, that feels like complete garbage. No, let's just not do that again. Unfortunately, the greater good and the people outside of the room and the gamers, they don't see all of this. They don't see it. They don't understand it. They have no real idea as to what's going on. But in an audio department, it's really, really essential that you understand and you acknowledge the fact that you have to actually update everything all the time. You have to have the most up-to-date information all the time. Otherwise, just one little thing can change how the game feels. A good example of this is everything burns at the same time. But that's fine. Weapons. Really, really good example of this. If you've got this massive bazooka, it needs to sound like a bazooka. It doesn't need to sound like a potato gun. So when we deal with that, we have to make sure that the audio can change depending on what the game designer is going to do. Like if a weapon, for an example, is a pistol and it deals 50 damage, But then the design team go, it's not really working. We need that to be a little less powerful. So what usually happens is in audio, they go, we've got this gun. It needs to go bang. OK, I'll do that bang noise. There you go. That's now in the game. OK, no problem. Gun goes bang. Yeah, that gun sounds really big now, and it doesn't really deal that much damage. So can you change the sound for us? Yes, I can change the sound. That's not a problem. Let me just get a Jira task in for it, and we can make those adjustments. Oh, yeah, that new thing that you just added, yeah, it's changed again. Dude, I've got 50 other weapons. How do we fix this as a problem? This is where letting your audio team design and build a system that can accommodate it is really, really, really helpful. Now, the reason why they change how much damage this gun might deal, it could be leveling up, it could be how it feels, it could be the balancing thing, and balancing, for anyone who's worked in game development knows, is a real pain in the pain in the neck. Because it's constantly evolving, it's never the same, and then when you play it with outside people, they go, whoa, this gun's OP, let's nuke that, please. So how do we deal with that? And there's no real right answer, but this is what I do. So here I'm going to show you some weapon signs. Now this is based on super huge guns. We're talking tank fire kind of weapons. So we're going to start with small. And then it's going to gradually get bigger and bigger. And the way we do this is we change the actual sound itself, but we also change the tail, which the bigger the weapon sound, the much more tail it has on it. Again, anyone in the audio industry knows you can just swap these out, you can sort of find them, pick them, ship them. But the real question is why do we need this many for one gun? Because this is what I do. I would take all of these sounds for one particular gun. Like in this particular case, this is just one particular kind of weapon, which is a tank, if you will, or a howitzer gun. This could be the same principle with a shotgun. It could be the same principle with a pistol. You can change the sounds that you're using based on the size and caliber of the weapon. And as you can hear, the bigger it gets, the more obscene it becomes. So what I do is I put these in Wise. Wise is an authoring software which is commonly used in the games industry. That's the example that I'm using today. If you don't know what Wise is, Google it. It's made by Audiokinetic, and it is the go-to authoring software. In audio design, we have the sourcing of sounds, which is when you get your microphones and you record everything, and then you have your editing, which is when you edit those sounds into something that is usable, and then you author them. That's usually done in Wise. Now, the authoring, that's the bit in between the recording process and the playing of the game sort of process. And then you have implementation, which is then taking it from the authored stage, and then this is how it actually sounds in context in the game. Now, what I've done here is I've got small, medium, main, large, extra, huge, super huge. That's all of the guns that you've just heard. And I put them in a blend container. Now, a blend container is basically a crossfading thing, so we can add them in a particular order, and then we can crossfade between them, depending on a particular number. In this particular case, we call damage dealt. That's an RTPC. In Wise, we call that a real-time control parameter. That's something that we can change in real time in the game. And that can be used for anything from RPM when you're in a racing game, revs per minute. It can be the velocity of something if you want to change the wind based on the velocity of somebody falling. That RTPC can change in real time. And the reason why I've done this, like here we've set it up to the minimum damage is 30, and the maximum is 1,250. These are arbitrary numbers. At the time that I was building this, those just so happened to be the minimum and the maximum amount of damage that a weapon could actually deal. And once you've got them in a blend track, we can crossfade between them using the damage dealt parameter, which we added in earlier. Now, the main reason why we want to do this is because now I don't have to iterate. I don't have to get a Jira ticket add in a sound for the gun, and then the designer goes, oh yeah, no, that needs to be a little bit more bigger. Can you change that? Yes, I can. That we've completely eliminated that just by adding in the one number that the designer can change at his end. So if he wants to change how much damage that gun deals, he just changes the number, and guess what? It automatically changes it for me. I don't have to do any more Jira tasks at all. I can go home. If only, if only. But it's a really good example as to how we can actually streamline the workflow and make sure that the work that we're doing is not just important, but also scalable with what other people are doing. It also means that we can use that one thing that we've already used, the RTPC, the real-time control parameter, we can use that for other things. Like, in this particular example, impact sounds. If it deals 30 damage, it's kind of small. The larger the amount of damage it deals, the longer. This is just based on dirt, by the way. You can do this with metal. You can do this with any kind of surface that you want to use. And those, again, can be changed based on the physical materials that are being used, which we'll look at later, and switches, which, again, we'll look at sort of soon. Yes, that's me kicking the bucket. You get an idea. So if we wanted to change one element, like how much damage a particular thing deals, it's not just the gun that's now affected, it's also the impact sound that that has. We can also use that same number to change the flyby sound. So if someone's firing at you with a pistol that's only dealing 30 damage, you can have a really nice wispy thing and a nice as it sort of hits the wall. If someone hits you with a 50 caliber and it's going to deal 1,000 damage, that should sound huge. I don't have to do anything. I've already done that. So once we've already done that, we can then move to a different sort of area of that. We can use that alongside other things like switches and states. Now, switches and states in Wise basically do exactly what it is that you think. It switches from one sound to another sound. And a state can change things based on something that you want to happen in-game, which might be a global thing. So, for an example, you might change to a stealthy state, which might adjust the mix. So, you know, we might have, the player is near dead state, so we might want to filter out the sounds and play a heartbeat in the background. So we can use states as something to control an environmental aspect or a mood, if you will. Switches, however, these are the things that are the secondary best friend of an audio designer because they switch from one sound to another sound based on real-time information. And physical materials is a really good example of this. Is the player walking on wood or grass or concrete? We don't know. So we check what the physical material is. Now, the physical material, that's actually handled by the environment art team. And I can't tell you how many bugs I've had from people when they've said, oh, this sounds really, really terrible because I'm walking on concrete, but it sounds like he's walking on grass. Can you please change it? Nope, that's an art bug. Why? It doesn't sound right. Yeah, I know it doesn't sound right, but it's not sound that's changing the physical materials, it's the art department. If they flagged it as being the wrong material, then the sound's going to play the wrong sound. So we can adjust that. So what else can we use with this? We can also use something what's called side chaining. Now, this is a very quick glimpse on the different things that we can use within Wise. I will come to all of this later in a kind of a climax, I'm hoping. Now, for anyone who works in the audio industry, they'll know what side chaining is. Side chaining is when you take the volume of one particular sound and use that output. In this particular case, you'll see the little green thing left and right. That's something most people recognize from their hi-fis and their CD players, where the louder it goes red, and then it just ducks down a little bit. What if that number, minus 48 to 0, what if we could use that to control the RTPC? So what if the sound that we're hearing here is minus 36, and the RTPC of the weapon volume is minus 48 to 0? So we can use the volume of one sound to crossfade another sound. Like, we'll use a good example of that later. So back to the switches and other sort of characteristics here. So a silencer switch. Now, everything that we have here, a switch is basically a condition that can be set from the game designer. A game designer knows that there is going to be a silencer that you can equip to your weapon. So that could be true. Is the player crouched? Are they walking? Or are they running? Those switches can be applied to footsteps, which switch between the relevant footstep sounds. Like if you're walking, it should sound one way. If you're running, it should sound a lot heavier. And if you're crouched, then it should sound nice and delicate, squeaky sort of sounds. We can have the armor levels, for an example. If we have light, medium, and heavy armors, we can switch between those, and that switches between the Foley sounds for that particular character movements. We have physical materials, as we said, for footsteps, which we can also have for impact sounds as well. So it's not just the gunshots that are hitting something that we have physical materials. It's also, am I walking on wood? Am I walking on grass? And we can apply that to the switches for the crouching, running, and walking. So running on gravel is going to sound very different if you're crouched and you're moving slowly on gravel. We want to know that information. And we can apply that to basically every other element of our effective audioscape. So if a player has light armor, a silencer attached, and the weapon deals low damage and is crouched, it's reasonable to assume that that player is trying to be stealthy, don't you think? It's not unreasonable. If he's got light armor and he's crouched and he's moving quite slowly, we could change other things. We could say, oh, he's in a stealthy state, so let's change the dialogue to whispering rather than talking. If you're wearing heavy armor and you're running and you've got an LMG and you've got dealing the heaviest amount of damage and you're not trying to be stealthy, switch the dialogue to be shouting. Those are the really small bits that you don't really think about that actually 100% immerses people into the game. You've not done anything. Your design department, all they've done is gone, we have 3 types of armor, and we have 5 different kinds of guns that deal a variety of different damages. That's the only information that you have from them right now. So we can change all of that. You know, when they're not being noisy, we can change there's all sorts of different things that we can change. We can move on from this. We will come back to that later. There's some examples as to how that all is intertwined. In the meantime, let's take a look at creating and adding an ambience. Now, this is a second part of the talk today. It's all related, I promise you. And we're going to get a little bit technical as well. We're going to start with birds. Okay, you can record a 20-second long loop ambience. And you can play that, and that'll be grand for about 20 seconds. But people realize that if you play the same thing over over and over and over and over and over again, it gets really annoying really quick. So the way I combat this is I record lots of little different tweets, little bird tweets, little things like that. And I cut them up and I put them in a little list and I say randomly pick one of these, and we randomly swap and we change the volume of the voice and we change the pitch of the voice so it's slightly different every time we hear it. And then we can put them in little sort of loops together, and we can say, all right, play this one, this one, this one, this one. Now play this one, this one, this one, this one. We can adjust the timing of that. We can adjust the pitch. So every time you hear it is actually unique and different. And this is a good example. This is just using 3 tweets, none of which from Donald Trump, by the way. Yeah, no, he can't do that anymore, can he? Yeah, sorry. But this is a good example of how we've only used 3 audio files at this particular point with the ambience, and they're 3 tweets, both of which are kilobytes in sort of size. So now it's time to get a little bit more technical now. Those that are familiar with Unreal Engine might know where I'm sort of going with this. I used Unreal Engine 4 for this demonstration. This is a free-to-get sort of pack. This is purely and simply just so you can visualize something that's actually going on. First of all, I create an ambient zone, which is a giant box around the area that I want to populate. And what I basically do is I say, I want somewhere in that zone, I want to play sparrows, woodpeckers, crickets, other forest birds. So you can pick the kind of bird, the breed of bird that you want, or crickets or animal. And we're going to randomly play that somewhere in that zone. And those sounds are just one shot, fire and forget, 2 or 3 tweets, the occasional cricket chirp kind of thing, the occasional knocking on wood from a woodpecker. Doesn't have to be anything special, just something fairly mathematical. I believe Unreal now has an actual node for this, which is get box extents or get random point in box extents, which does make this fairly redundant now. But as you can see here, we can add like a delay, and we can say like randomly between 1 and 5 seconds play this. And that kind of, this is what it looks like. Oh, does it? Yes, it does. Nothing technical to go on here. Everything's fine. So here I've visualized it by spheres. You wouldn't really see the spheres in the actual game. They would be invisible. But this is purely so you can see what sounds are playing, what they look like, and where they are. The wire mesh sphere around it, that's the roll-off. That's the distance attenuation for it, so you get a good idea as to how far or close you have to be. So why would we bother doing this? What's the point? Well, by only using 3 tweets, a cricket and a woodpecker knock, we've created a dynamic ambience that's never the same twice, which means the player can stay in that one area for an hour if they want, and it'll be completely different for the entire duration that they are there. That's full immersion that you've got. In this particular example, I've kind of condensed it all, so you will hear some repeating sounds, but that's as designed in this particular instance. There's nothing else playing here. This is just the birds and the one-shots. Underneath this, you can play like a small white noise bed kind of thing. You might also decide to have some tree rustling sounds in there. That adds, again, to the sort of ambient bed. And when we deal with the trees, what we do is this is going to result back to the side chaining thing that we used earlier, where we have the tree sounds that are nice and calm, and then we have the heavy moving of trees sort of sound. And again, we use the RTPC. We use the RTPC to sort of change the veracity, if you will, of the... Yeah. Now in the background we have thunder. Now here's where it gets interesting. It's not just a one-shot of the birds that we can use. We can use a one-shot of pretty much anything. So let me just poof that over there. What I did with that example is I didn't just use birdsong. I also used tiny gusts of wind. And I said to the sidechain, if this gust of wind gets this volume, we crossfade from a light tree movement to a heavy tree movement. What you effectively have there is not just a dynamic game world, but an interactive game world, which actually changes things as you're in that space. There'll be an example of this used later. So if we can play a sound, then we can stop a sound. What if we applied something called on loud sound? What if we wanted to play or stop a sound based on an action that we already know is going to happen? So if we flagged a sound as being a loud sound, and every time we heard that loud event play, it did something. Okay? A really good example is a gunshot. What if a gunshot is classed as a loud event? And by firing that gun, we stop the birds from playing. If we stop the birds from playing, then we can play a sound as well. So what if we played the sound of birds flying away? So this is a good example of exactly that. Using the exact same system that we've just built. This is all in Unreal Engine, by the way. I couldn't show you the visuals for this for many reasons. And then after a certain amount of time, we reintroduce the birds. What if you swapped to a crossbow? That's not very loud. That's a stealthy weapon. What happens when you fire that? The birds don't fly away. So now we have an interactive ambient system that isn't just based on gusts of wind playing that affects the trees, it's also based on what the player does. Now, a loud event could be anything. If you're on a stealth game and you're like walking through the woods and you step accidentally on a twig that snaps really loud, maybe you want some of the wildlife to react to that. That's how I do it. So far, these are the systems that we've been using. We've built a weapon system that scales based on what the designer does. We've built an impact system that, again, can scale depending on how much damage that weapon deals. It changes and scales accordingly. We have a character locomotion system that switches the physical materials for the footsteps, can change between you being crouched and running and walking. It can change the foley that you're using based on the armor type that you have. There's lots of things. That's just the movement. We've got a dynamic dialogue system that we can now change. If we are shouting, or if we're talking, or if we need to whisper, all based on information that we already know. We have an ambient system that is never the same twice, that because it's actually in a box, we can move that to different biomes in the game. We can say, actually, should we have these kind of birds in a forest? Should we not do something else? What if it's a city and we don't have birds? Well, you replace the bird song by distant car horns. Suddenly you have a cityscape with traffic jams. You can add in very distant roadwork sounds. It's a one-box-fits-all kind of situation. But you can also have time of day associated with that. So you can say, okay, well, maybe we don't want birds to sing during the night. Maybe we want owls to hoot instead. Exactly the same system, but we base it on time of day. Loads of things that you can do. And we have an accidental stealth system that we've somehow managed to acquire. We're not entirely sure how we managed to do that, but because we know how all of this stuff works, and we've already done the sounds for it, we actually can use a stealth system. This is a good example of the sound system, the whole of that you've just seen, apart from the dialogue system. This is actually 9 to 5. 9 to 5 is a free-to-play 3 versus 3 versus 3 shooter. It's now, unfortunately, it's now been deprecated, and this is a pre-beta gameplay, hence the not-so-white boxing purpleness. So here we can hear different physical materials. We have distant winds, one-shot winds. Again, this all works exactly the same system that we've already looked at previously. But we can also add other little things like, what if there's a coastline? Now we wanted a specific coastline here, so how do you get a coastline to sound like it's from a coastline without having lots of sounds? In this particular case, we just had one sound, which was the coastline, which moves along a spline, follows the player as it's walking. That way we only need one sound, and we don't have to have multiple instances of this. We did the exact same thing with the tree line, and in this rocky area, I added in another ambient zone and filled it randomly with rocks falling, which you may or may not hear. I don't know. We'll have different kinds of birds for the environment that we're in. In a minute, you'll hear what's called a tree line, which we basically did the trees the exact same way that we would the coastline. We have one spline which plays the sound that follows the player. But the tree sound also has the RTPC attached to it, which is going through the side chaining of gusts of wind. And you know the best thing about all of this? It hasn't cost anything. This is all stuff your audio designer can do on their own. There's no designer or coder needed for this. You just need to know what those. You just need to know what the parameters are going to be called. So we didn't use anyone. This is all something that I did on my own. The first thing we did on 9 to 5. Everything that you see that we've discussed is stuff that I immediately did. Now, it's not the most efficient way. No, not by a long shot. But what it does do is it does mean that I didn't have to completely iterate on everything all the time while actually not progressing on things that I actually needed to progress on. Lots of time and effort needs to go on all of these elements, and I was the only audio designer at the company at the time. So I had to make myself most efficient that I could. Once we know how much damage that particular gun's going to deal, we can get rid of the scaling element of it and replace it with a custom-made, absolute specific sound just for that one weapon. And we can get rid of everything else that we don't need. That frees up a lot of voices, it frees up a lot of optimization elements, makes things really, really, really better for the final product. What's not good for the final product is me spending 3 weeks on one gun when there is 50 guns that I need to work on. In conclusion, and there's a lot of bullet points here. You can probably read through those, but the main thing is by allowing your allowing your audio designers the ability to design freely and build systems of their own volition and say, how do I want this system to work? What should this system do? What you're effectively doing is you're giving them the tools, the right tools, to create a dynamic game world, which is not only immersive for the player, but also immediately has cause and effect and consequences. Now, this is the bit that everybody kind of gets a bit shaky on, because they go like, well, what's the point? Why should we do all of this? Surely you could just put the audio in at the last minute, which is usually what happens. People say, oh yeah, maybe we should get an audio guy in for this. When does it ship? 3 weeks. Yes, sure, but that's not the answer to the problem that's plagued the industry for years, which is crunch. Audio teams are inevitably the last people standing, and usually they're doing 70 or 80-hour weeks for exactly that reason. What if you brought in your audio person from the very beginning of the project and you went, go nuts? I did all of that with no coder and no designer, just me on my own, because I decided this is what I want it to do. This is how I want the game world to be. This is the kind of thing that I want to do. And because my company was gracious enough to give me the latitude to do it, the game benefited massively as a direct result. Yes, we still had to optimize. Yes, we still had lots of things that we had to do, and it was a definite journey. But almost immediately, every stakeholder that played the game was immediately immersed from the very beginning that they played the prototype. They were engaged and they were immersed and they were invested in the final product. And if you as an audio team, if you want that money and you want to be taken seriously, that's what you got to give them. Give them something awesome, absolutely immediately, within the first month of you being in the company. I promise you, anything that you say, I don't like how that works, will be taken much more seriously than if it's taken otherwise. And nothing, and I cannot stress this enough, nothing will make your life as a game developer easier than enjoying what it is that you're doing and enjoying the people that you're working for and feeling that your voice is heard. If you don't get any of those things, regardless of the department that you're working in, you're not going to get it. And for anyone that runs a studio or anyone who's a producer, let your audio designers design. Any questions?
Thanks a lot, Robert. That was amazing. I guess we could start with questions. Please raise your hands. Yes, we have over here.
Hey Robert, thank you for the talk. My question goes regarding like the last thing that you said about like getting your audio team earlier, because I think that's something working on a company that you kind of run against a bit. So I guess my question is, what type of arguments did you use when you started at the company to get them to like, okay, because to work in the game, I guess you need the code, you need access to the repo, you need a bunch of things before you can actually implement Wise. Maybe you had to do the implementation yourself, right? So what types of arguments did you use to like, okay, please let me do this as soon as possible?
Well, my first go-to response with that is almost always going to be, how many awards were won for game programming? How many awards have been won for game programming? How many awards have been won for game best audio? You're welcome, boss. It's a bit of a cop-out sort of thing, but it is a really good example of like, actually, audio is super important because that is fundamentally what tells people how to play the game that you're making. Does it have voice actors in it? Do those voice actors, are they part of the tutorialization and the first-time user experience? How do we telegraph information to players? It's done through your sound. Yes, there's some UI elements done there, but how many people have played a game where the UI is absolutely bonkers and you're like, yeah, no, not interested. Perfect example of that, Portal. An absolute masterclass of video games and the best written bad guy I have ever seen, and you see her once at the end of the game. None of that would be possible without excellent sound design and sound direction. How do you sell that? Ask your bosses what's the worst sounding game that they've ever played. And if they can give you a list, ask them why they think it sounds shit. And I bet you the reason is, well, because they probably shoehorned in the audio at the oh, I see where you're going with this. Any game that has been successful, that has had 100% incredible audio, is because they have had in-house people from the very beginning of the project, including, but not limited to, the prototyping. Because we've all been there, like, as an audio designer, I've been in situations where I've gone to, I've been called in to do something, and I've gone like, this is unrealistic in the time frame that you have. Or like, yeah, we want to do this cool, really cool dynamic dialogue thing. Yeah, that would have been possible 9 months ago, but like now, no, you can't do that. Why not? Because we don't have an engineer. We don't have code support for that. If you'd have told us like 9 months ago, we could have built all these systems to support this system, which you want to shoehorn in at the last minute. No. So if you're building a sports game and you know that sports commentary, like hockey for an example, and you know that the dynamic dialogue is going to be reacting to which players are going to have control of the puck, the dialogue is going to be the first thing that you look at and say, well, that's got to be a super important thing. Maybe we should get a dialogue designer in to help make sure that that dream is realized. Likewise, if you're playing a racing game, you wouldn't just put the sounds in last. If you're doing a racing simulation game, you want, like, the reason people buy simulators is because it's realistic. You wouldn't shoehorn that in at the last minute. No, of course not. Why should any other video game be different? Mobile is a very different kettle of fish because mobile games are very, very, very different to mobile. Mobile's different to AAA, I guess, and the use of middleware, things like that. And usually, whenever I'm designing for mobile games, I'm not really designing for people playing the game. I'm designing for the other people in the room that has to endure them. And that's a different conversation with management for mobile games, especially if you're working on kids' games, because you're not designing sound for kids' games, you're designing the sounds for the adults, because they're the ones that are going to have the kids in the back of the car for 10 hours while they drive the other side of Europe. Any other questions?
All right, thank you. Ladies, please.
First of all, thank you very much for this very interesting presentation. I'm curious about the ambient boxes you were explaining, and how does it work with multiplayer games? Do these boxes clash if different players make different decisions, for example, or yeah, I don't know, like with multiplayer games,
Yep.
how does it work?
Very, very good question. 9 to 5 was actually a multiplayer game. It was 3 versus 3 versus 3. And basically, the ambient systems that we have are client-based. So they are client-based in so much as I can hear a bird song, but the person who else is on my team might not necessarily hear that bird at the same time. What is server-based is the loud event, because it's a gunshot, and if he fires his gun, I should know that he's fired his gun. That's a server trigger anyway, because that's how multiplayer games work. But what we then do is we then say, okay, well, we can stop all the birds because that loud event has happened. Blimey. However, if we decided that we wanted to use the stealth system, we wanted the gunshot to trigger the birds flying away, that would be server-side as well, because they would be positional, and we would know, oh, there's birds flying away over there. Maybe that's where the enemy is. But we would only do that very, very, we might use that conservatively, because anything that you trigger on the server is going to have some implications when it comes down to optimization. It may be that in particular areas we have a priority system that says, okay, what's the most important sound that people need to hear? It's the guns and the footsteps. Do we care about birds flying? No. Kill it. But if there's only 2 players in that area of the game at any one particular given time, and we want that to be part of the system, like the stealth system, and we want that to be part of the game mechanic, then that has a much higher priority, because that's how the game works. But in general, for the game ambience, most of it is all done client-side. Unless we're having key elements there, like the thunderstorm, for example, we might want to tie that in with a stealth system, so that if you have a sniper rifle, you can time that with the flash, 2, 3, bang, with the thunder thing. That would have to be that would have to be server-side as well, because otherwise you'll end up like, boom, oh, what was that? Oh, that wasn't a stealthy shot at all. So things like the weather system, that might have to be server-side. But again, when we're dealing with a weather system, that's more of a tech art kind of thing, because that might have a bearing on the game. Like, you can't have it raining for one player and sunny for another player. That's just not how the game works. That's not how weather systems work, really. So in that particular case, we would talk directly with the tech art team, and we'd find out sort of how they're going to be dealing with the optimization side of the weather effects and things like that. And we'd talk to then other key stakeholders, whether it be the lead design team or the narrative designer or the executive producer, and we'd scope things, and then we would go to the technical director and beg, please, can we have this tiny little thing? But other than that, we would be sensible in how we approach it, and everything that we've done there is all client-side, apart from the birds flying away, which was a client-triggered sound. And considering that the usage of that is so very minimal, and we've created what we call a conductor system, where we basically look at the priority of what's the single most important thing for the player to hear. If that's really down here, then we just nuke it, we get rid of it, because the voiceovers might be the most important thing, the UI might be the most important thing, gunshots, footsteps, most important things that we want to hear. So again, depends on the project that you're working on, depends on the priority and the gameplay, but yeah, that's how we would do it.
Thanks, Robert. I guess we could have one more question. Yes, ladies in white, please.
Thank you so much, Robert. Great talk. I was wondering, what is your approach for organizing the audio systems in the game engine? Like, do you have a master blueprint for all of the systems or something like that?
Yes. The ambient system, the ambient zones, that was a blueprint that I had, and basically it had its own, like, you could click, drag that into the game world, you have a box. And then you have like a little array that you can go, I want this bird, this bird, this bird, this bird, bum, 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 bum. You could add in a list, and you could have like a timer. So between 1 and 5 seconds, a little tick box. I want this as a loud, stop on loud sound, or I want this to play on a loud sound. And click and drag, right, and just move that and scale that into this area. And you can overlap them so that you can have a seamless transition. And then what we would do is we would have just a single bed sound, which would be like a 2D sort of ambient noise, if you will, that would just be like almost like a room tone kind of thing for outside. So it doesn't, fairly looped seamlessly. There's nothing, no discerning sounds in there, because we want those discerning sounds like birdsong, crickets, things like that. We want to trigger those specifically for particular areas. You know, like if you're in a mountain top, for an example, you wouldn't want to hear crickets. So, but you might want to hear rock falls and things like that. So it's the exact same system. If we're in a city centre, again, we can use car horns, things like that. And we just drag that in. Once we've got the blueprint done, once we've got the basics of it done, I can click and drag that anywhere I want. And what we have is we have the ambient zone, and then we have like an activation zone, which we put with it, which this does not work unless there is somebody in this area. If there's someone in this area, we switch it on. If the player leaves, it switches it off. That guarantees that we're not playing sounds that nobody's hearing. So we end up in a situation then where not only is the work that we're doing actually fairly streamlined, we just click and drag, put that in there, boom, 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 but it only actually is active when there's someone in that game, in that area of the game world. If they're not in that area of the game world, it doesn't play the sounds. It's not clogging up any of the technical side. You know, it's not using up any of the voices. It's not using up any of the bandwidth that we might have. And it's really, really optimal. And the second reason why we would do this in this particular way is for the optimization side of things. You know, we have an entire interactive ambient system that consists of only 15 files, all of which are less than 1.5 megabytes in total. Your technical director will love you for it, because it doesn't cost you anything by direct comparison. You know, there's nothing going on there. That also means that you can be a bit more creative, and you can actually invest with the memory side in things that actually do matter, like guns, dialogue, music maybe. You know, all the things that make a game good, you can invest that there, knowing full well that the ambience and the game world itself is alive and breathing. But like all of that took me less than 3 days to do. Yes, I already knew how to do it. It didn't take me very long. I've been doing it a very long time. But it's 3 days worth of work for what is effectively a 4-year process of making a game. Over the years, you'll improve it. You'll make things a little bit nicer. You can add in niceties here and there. And then optimization comes, right. What can we get rid of? What do we need to keep? What can we work on? 90% of the work that I did there shipped with 9 to 5. That's actually how a lot of people are doing game ambiences across multiple different sort of platforms. The reason why that works is because it's so small footprint in your memory. You can use it across the Switch, Nintendo DS. You can use it on any platform that you want because it costs you nothing. You get a lot out of it in response.